Hey everyone, this is my first video for Physics 210, and this is my first video with this screen, so bear with me a little bit here. Before we begin, just heads up, these videos are purely the videos of the in-class examples. It's an opportunity if you want to go through and review it with more than the worksheets that are given, you have access to that. So without further ado, let's begin. So today we talked about velocity versus position, and the first thing we did was we talked about that in graphical form. So we had time, make sure I give myself a little bit of space here, time versus position graphs, and we wanted to turn those into, my marker's not doing so hot here. Time versus velocity graph. Okay, we can see it. And what we have for our first problem is we were given that we're working at a time scale between 0 and 4. So 1 second, 2 seconds, 3 seconds, 4 seconds. And we can kind of assume that this time is in seconds. And then position, we have a position that is varying from 2 to 4. So I'm just going to put in exactly the graph that you should have given. And we could probably assume, it's not given, but we could say that this is units of distance, which our base units of distance we're going to use in the class are meters. Okay, let's see if this yellow is any different than the green. So at time 0, we are at position 2. At time 1, we are still at position 2. Boom. At time 2, we have jumped up to position 4. So a line like that. Time 3, we are still at position 4, I believe. And at time 4, we have dropped back down to position 2. Nope, nothing I draw on these boards is to scale. And with this, we are asked for this velocity versus time graph. First thing we can do is we know, I'm going to be careful about this one, because we're not going to use quite the same axes. We know that time axis has to be the same because they're both the time axis, and we can say that's in seconds. Velocity, base units for velocity are going to be meters per second. And our velocity line, I believe that I already gave you, we're going to need from -2 all the way up to 2, meaning that in reality, this bottom line that I drew is not, oh great, first time using the board, sorry, is not going to be down here. I actually have my my x-axis right through there. Let's do this. Okay, so let's start by talking about this in terms of equations, because that should be fairly simple for us, hopefully. So between 0 and 1, what I can do is I can write our normal equation right up here. We can say that x at time 1, so that's what that little 1 is symbolizing at time 1, is going to be equal to the x at time 0, right there, plus our velocity between time 0 and time 1, times our time between 0 and 1. I could write this as my delta time, which is going to be equal to the time at 1 minus the time at 0. Perfect. With that, we can start filling in these numbers. x at time 1. Well, at time 1, my position is 2. So that's going to be 2. Is going to be equal to x at time 0. That is also 2. Plus our velocity. Well, we want our velocity because we're trying to graph it over here. So that we're just going to leave as the variable. Times t0 minus t0 to 1, or t1 minus t0. So time at 1 is 1. Time at 0 is 0. That is 1. So subtract the 2 over. 0 is equal to v times 1, or 0 is equal to v. We have a velocity of 0 between those two times. And this works because that velocity is constant. It's a flat line or it's a straight line. Anytime we have straight lines, we have a single velocity between the two. So we can say that our velocity at time 0, between time 0 and time 1 is going to be 0 meters per second. So we have a straight line right there. First piece all set. The other thing you can do is you can look at this line here and say, what is the slope? And all the slope is the difference from the second position to the first position. So 2 minus 2, which is 0, divided by the distance on the x-axis, so between 0 and 1, divided by 1. 0 divided by 1 is 0. We have a velocity of 0 between those two times. Perfect. Next thing we're going to do is we're going to look between time 1 and time 2. And I'm going to go a little bit lower on the board. It's going to be a little easier to see, hopefully. We have x at time 2 is going to be equal to x at time 1 plus v between 1 and 2 times my time between 1 and 2. X at 2 is 4, because that's right there. X at 1 is going to be 2. That's right there. Our velocity is what we're trying to solve for. And our time, 2 minus 1, is 1 second this is happening between. Subtract the 2 over, we get 2 is going to be equal to velocity from 1 to 2 times 1, which is just velocity 1 to 2. So between 1 and 2, we have a velocity of 2. So at this moment, at time 1, we are jumping immediately from a velocity of 0 to 1 to a velocity of 0 between 0 and 1 to a velocity of 2 between 1 and 2. Again, we can do the same thing talking about the slope. We can say that the difference in the change in height, which is 4 minus 2, which is 2, divided by the change in time, which is 2 minus 1, which is 1. 2 divided by 1 is 2. There's our slope. Easy enough. Going a little bit quicker here. Not going to write out the full equations. Between 2 and 3, we've got no change in height. We've got no change in position, that is, change in height on this vertical screen in front of me. So we're going to have a velocity of 0 between 2 and 3, like so. And then between 3 and 4, we have going from 4 to 2. That would be, if I were to write out my equation, 2 is going to be on the later variable. So this is x4. I guess I can write this out too. I have space. Is going to be 2. X3 is going to be 4. So this is x3 is going, oh, not quite like chalkboard. I can't use my finger to erase it. I've got my velocity times 1 because this is my time. Between 3 and 4 is a change of 1 second. Subtract 4 over, you're going to get negative 2 is going to be equal to v. We always have the later time. I know in class we probably talked about this equation as x final is equal to x initial plus velocity between those two times the time between those two. I'm just making it a little bit more specific as I write these equations because x final is x4. It's the time is the position at time 4. X initial is 3 because we're only looking between those two spots. So we get -2. And we can draw that. And we're seeing these jumps. Our velocity graph is a bunch of horizontal lines because if we have a straight line in position, whether it is flat or angled, we're going to have a flat line in velocity. Just how it works. That is question 1.